Good morning gentlemen, hope you are doing good. Today in this video, we are going to do Michelson Morley Experiment. We will also derive the derivation and get the outcome of this experiment. So gentlemen, let's do the Michelson Morley Experiment. So I have made the experimental setup of this experiment. So gentlemen, this is the source of light as from where beam of light is going towards our experimental setup. Gentlemen, this ray of light coming towards half silvered plate P, which is tilted at an angle of 45 degree, and as soon as the light strikes the point P, it goes upward to a plate which is placed at an angle of 90 degree and then come back to the telescope, and the light which tilted to 45 degree goes to again plate which is placed at a 90 degree with this setup and strike and comes back to plate P dash, which is again placed at an angle of 45 degree. It then goes to mirror M2 and then comes back to point P. So gentlemen, what is happening in this experiment is that we are experimentally checking the ether drag. Now let me explain you this diagram more deeply. First of all, this ray of light goes to point M1, and till the time it reaches point P, this plate moves to M1 dash point, and this light strikes to this point, and the same thing happening here also. When the light comes to point P dash, it goes to mirror M2, but till the time it comes back to point P, the plate M2 dash is moved this much of distance. So let's start. So let us consider that the frame of reference moves with velocity c minus v in forward trip and c plus v in backward trip. Therefore, the time taken by the system wave P to M2 is given by T1. The time difference measured as follows. So here T1 is, this is length L from point P to M1, and from this point of telescope to M2 also the length is L, so these both lengths are same. Okay, so T1 equal to L upon C minus V plus L upon C plus V. As we know that distance is speed into time implies time is distance upon speed, right gentlemen? So T1 equal to L into C plus V plus L into C minus V upon C minus V into C plus V. So it becomes L into C plus V plus L into C minus V upon, this is the formula of A square minus B square is A plus B into A minus B. Just a second. So gentlemen, it becomes C square minus V square. Now T1 equal to L into C plus V plus C minus V, taking L common, upon C square minus V square. Now T1 equal to 2LC, because V and V cancel out each other and it becomes 2C upon C square minus V square. Now T1 equal to 2LC upon, taking C square common, it becomes 1 minus V square upon C square. Now from this point t1 equal to 2L upon C into 1 minus P square upon C square. This is the value of T1. This is our equation number 1. Now look at the diagram, and in this diagram, in right angle triangle P M1 and M1 dash, on applying Pythagoras theorem, we get, first of all, we have PM1 equal to L, M1 dash equal to VT dash, this point, gentlemen, and we have P M1 dash equal to CT dash, this point. P and M1 dash is CT dash. Now moving forward, we have PM1 dash whole square equal to PM1 whole square plus M1 dash whole square. Now putting these values in this equation, we get CT dash whole square equal to L square plus VT dash whole square. Now C square T dash square equal to L square plus V square T dash whole square. Now taking T dash common, we get L square upon C square minus V square, because this moves to right hand side and it becomes, when we take T dash square common, it becomes C square minus V square, which comes into the divide of L square. Okay, now T dash equal to under root L square upon C square minus V square. Okay, so finally T dash equal to L upon C square minus V square, and now taking C square common here, we get C square 1 minus V square upon C square under root. So finally we get the value of T dash as L upon C 1 minus V square upon C square to the power 1 by 2, means under root. Okay, now we have to find total time. So total time taking from P to M1 dash, from point P to M1 dash, and from M1 dash to P dash is equal therefore total time is T2 equal to 2 of T dash equal to 2L upon C under root 1 minus V square upon C square. This is equation number 2. Now we calculate the time difference between the two journey, between the two journey implies we have to find delta of t equal to t1 minus t2 equal to 2L upon C 1 upon 1 minus v square upon c square. This is the value of t1 that we have find here, minus 1 upon 1 minus v square upon c square to the power 1 by 2, which we have find in this page, right? So we find that del t equal to 2L upon c 1 minus p square upon c square to the power minus 1 minus 1 minus v square upon c square to the power minus 1 by 2. Because this is the case of, this is a rule of math, like let me tell you, 1 upon a equal to a to the power minus 1, which we have used here. When this denominator goes to numerator, its power become negative, right? So now applying binomial theorem. So let me tell you the formula of binomial theorem. It is, if the equation is of the type 1 plus x to the power n, it becomes 1 plus nx plus nx square upon factorial 2 and so on. And if the formula is of 1 plus x to the power minus n, then the formula is 1 minus nx plus nx square upon factorial 2 and so on. So applying this formula in t dash, we get del t equal to 2L upon c. Opening this equation, we get 1 plus minus v square c square minus 1, it becomes plus, so plus v square c square minus into minus 1 is plus 1, so 1 minus into minus is plus, into minus 1 by 2 it becomes minus, so minus v square upon 2c square, because it multiplied by the power of minus 1 by 2, so like this. Moving forward, after this we get del t equal to 2L upon c under bracket 1 plus p square upon c square minus 1 minus p square upon 2c square, implies del t equal to 2L upon c into 1 by 2 v square upon c square. So del t is lv square upon c cube. This is our equation number 3. Now the corresponding path difference delta equal to c delta t, then delta equal to c, putting the value of delta t in this equation, we get c into lv square upon c cube. We get delta equal to lv square upon c square. This is our equation number 4. Now this is the last point of this derivation. If n be the number of fringes that we see from the telescope, then the path difference given for consecutive interference is delta equal to n lambda, implies putting the value of delta, we get n equal to delta upon lambda equal to lv square upon lambda c square. So n equal to lv square upon lambda c square. This is our equation number 5. Okay, now the total path difference for completing the journey is twice of the previous path. So it means n equal to 2l v square upon lambda of c square. Now, in Michelson Morley experiment, we have some consideration like L equal to 11 meter, velocity of the earth is 3 into 10 to the power 4 meter per second, and the visible fringe wavelength, that is lambda, equal to 5.5 into 10 to the power minus 7, implies n is 2 into 11 into 3 into 10 to the power 4 to the whole square upon 5.5 into 10 to the power minus 7 into 3 into 10 to the power 8 whole square. This is the speed of light. Finally, we get n equal to 0.4. So this is the derivation. So let me tell you a little bit of theory about this topic. So Michaelson and Morley were extremely surprised to see that no shift in the fringe was observed when the interferometer was rotated through 90 degrees. Michaelson and Morley repeated this experiment in different places at different time and different height, but they always found no shift. Hence, the hypothesis of the existence of stationary medium was disapproved. Now, some of the interpretations of the Michelson-Morley experiment which are negative, are ether drag hypothesis, Fitzgerald-Lorentz contraction hypothesis, constancy of speed of light hypothesis. So gentlemen, this is all about this topic. Hope you understand this topic. If you want some numericals on this topic, do comment below, and please subscribe to my channel, like the video and share among your friends. If you have any suggestion and want any separate topic to be discussed here, do comment below. In our next video, we will learn Lorentz transformation. Thank you.